A very good morning to all of you. I welcome you all to this course and the lecture series on heating and cooling load calculations. So directly moving on to the introduction of this heating load and cooling load. Here you can see a picture on the right. So this represents a simple living room where four people are present. So they are the occupants of this room, and in addition to the occupants, you can see a laptop which is placed on the table and also a mobile which is placed on the right. So there are some electronic gadgets as well as four occupants inside this room. Outside this building, we can see the solar energy, that is source of solar energy, that's sun. So the heat from the sun is falling on the roof as well as the walls as well as the glass opening. So this represents a glass opening, right? And some amount of heat is passing through the roof as well as through the floor. So this is what is portrayed in this building, or what is understandable from this picture, right? So before moving on to the step by step and the systematic procedure of calculating, first let us know what is meant by heating load and cooling load. Now you take the winter season. The room itself will be chill. So you require some amount of heating for the room. So you'll be using a geyser or a heater to keep the room space. So the term space, wherever I'm going to mention in this lecture, it refers to the living area inside the room, right? The likewise in the summer season, the temperature, room temperature will be hot enough, and you require some cooling sources, might be an air conditioning or a fan. So when we have to go for heating, when we have to go for cooling, we know very well. But what is the amount of heating that is required for a building? We do not know. What is the amount of cooling that is needed for a building? That is also not clear. For that purpose only, we are moving on to heating load calculation and cooling load calculation, right? Now, from this picture, you can see that the solar energy is falling on the building, right? So that there is a heat source, and that is nothing but the solar heat source. And when you consider the space inside the building, you can see that there are laptops and some additional gadgets. So this will make you understand there is some other heat that is generated inside the building. So these are called as internal heat source. Now, there is a balance equation required for this entire series. That balance equation is nothing but when you sum up the solar heat as well as the internal heat generated in the building, it will be equal to the heat losses. So heat losses is U into A into delta T. So that's what we are going to write here now. I'm just writing the heat balance equation. I told you there is a heat source, right? So this is the heat source. I'm representing it by Q solar plus, and this is the internal heat generation that is due to the participants. So that I'm writing as INT. Okay, when you sum up these, it will be equal to U into A into T inside, that is inside temperature of the room minus outside temperature of the room. Okay, in this, if I want to find out the T out, okay, at balanced conditions, then I will simply rearrange this entire equation as T out, B represents balanced, right? So that is going to be T in minus Q solar plus Q internal heat divided by UA. So here the U represents universal heat transfer coefficient, and A represents area of this building. Is that clear? Now, I told you we very well know whether heating or cooling is required. Okay. But in exactly in terms of temperature, how much is needed? How much is the heating load? For that, there is a thumb rule. You can just note down whenever this T out, that is balanced condition, the outside temperature at the balanced state is less than the outside temperature, then definitely we have to go for cooling of the building. And the second case is whenever the same outside balanced is greater than that of T outside, we have to go for heating of the building, right? So this is the thumb rule, right? You'll have to remember. So what we have seen here, we know this is a room. We know where all the solar heat is entering and where is the internal heat generation. When we sum up these two, we will have the heat losses that is occurring. That is, the summation of the heat is balanced by the heat losses. So outside temperature, we are calculating at the balanced state. If this outside temperature is lesser than, that is at the balanced state, if it is less than the out temperature, then you have to go for cooling of the building. Now, if the same outside balanced temperature is greater than the outer temperature, we have to go for heating of the building. This is what, in very simple words, we can make this clear. Okay. Now, you look at the same figure, look at this figure. Here, we have considered the occupants as well as the devices which are present. Imagine we are not considering these occupants and we are not considering this solar source in case of winter season. That is, we are totally neglecting the solar source and we are not considering the occupants, and we think that the outside temperature doesn't show much fluctuation. And in this case, if you calculate the load, it is going to be very simple. You will be arriving at an answer in few steps itself and it will be very easy. This is called a steady state calculation. But this method is absolutely not right. Why it is not right? Because it will give us a misconception of how much of load that has to be given to the building, right? So how much of heating load is required? We actually get a misconception only because these participants and devices present will also contribute for some amount of heat generation. So which if we are going to neglect, will definitely be on a wrong side. So it is always important to account all the possible heat sources, even though they are negligible. We have to account it and then only proceed with the calculation, right? Fine. So now we are going to see the procedure. I will always call this heat loading calculation as a systematic procedure and stepwise procedure. Once you understand the steps, it will be very easy to arrive at the solution, right? So before moving to these steps, there are four terms which you need to know. The first one is sensible heat, next is latent heat, and then you have CLTD, and then you have SHGF. So the first one, that is sensible heat. The sensible heat is nothing but the heat that is realized due to change in temperature. When I say temperature, it is dry bulb temperature. Okay. The next is latent heat. So this is the load or the heat that is realized due to change in moisture content. And the next you have the cooling load temperature difference. So cooling load temperature difference is the difference between the temperature inside the room and outside the room. If it is a building, then it's inside the building and outside the building. And next you have the solar heat gain factor. So solar heat gain factor means in any building you take, you have definitely doors, glass windows, and some other glazing you have for fancy. Okay. So there will be direct heat gain through this. This is called as fenestration. So solar heat gain factor always accounts with the heat that is made possible through fenestration process. So understood these four. Moving on further, whenever I say load, heating load, whenever I say heating load, there are two types. One is external. So this is the solar energy, and the other one is internal. So this is due to the participants and appliances. So the first thing that we are going to do is we have to estimate the external load, right? To estimate the external load, you have three subcategories. The first one is heat that is passing through opaque surfaces. Okay. The next you have heat that is passing through fenestration. So when I say fenestration, the glass and windows should come to your mind. When I say opaque, the walls should come to your mind, walls, roofs, etc. And then you have heat infiltration. So this is the amount of heat that is entering the building. Okay. So these are the three ways by which you can calculate the external load. Fine. To calculate this heat through opaque surfaces, this is nothing but U into A into CLTD. So already we have seen what is this U and A. Again, I'm repeating, this is universal heat transfer coefficient. A is the area and this is the cooling load temperature difference, right? So next is when we calculate the fenestration, this is unshaded because we are talking about the windows, right? And the glass that into SHGF, right? And then you have the shading coefficient and then you have the CLF. Unshaded area, it refers to the area that is exposed to solar radiation, and SHGF is a solar heat gain factor, which I told you. The shading coefficient is actually a constant that will be given to you in the question, or you can take from some standard tables. Now, there is one important keyword that is called the CLF. So cooling load factor. This, I'll tell you what it is. Imagine the radiation that is entering the building. Say there is 40% of radiation that is entering your building, and all the 40 is not being observed by the space inside the building. What happens is this 40% of heat actually is absorbed by the floor, by the roof, by the walls, and also by the furnitures, whatever is present in the room. And all these are different objects which are made of different thermal conductivity. So based on their thermal conductivity, they have the capability of absorbing the heat, and then after some period of time, they'll be reflecting it to the space inside the building. It means the room itself will be heated up. So when 40% is falling entering the building, it doesn't mean all the 40 is being absorbed by the air. It falls here and there and then it is re-radiated, and after some time only this air inside this room gets heated. So I can say only 30% of heat is being absorbed. So I can see a decrement factor and also a time lag. So this decrement factor and time lag is accounted in the CLF. So this is called as a cooling load factor. This cooling load factor will always be less than 1. So this is how you have to calculate the fenestration. So unshaded area of the unshaded region into the solar heat gain factor into the shading coefficient and the CLF, right? And the decrement factor. So this is how you have to calculate the fenestration. Now coming to this heat transfer by infiltration, this is the actual heat that is entering into the building. Here you cannot calculate directly. Instead, you have to calculate the sensible heat as well as the latent heat. As already described, sensible heat is something that is realized due to change in temperature, whereas latent heat is realized due to change in moisture content. Fine. So this sensible heat is calculated by this formula mCp into delta T. So delta T is T naught minus Ti. So here I can write MO. So O stands for outside temperature condition. And this T, right, outside temperature and inside temperature, it represents the dry bulb temperature only, right? And next, here you see for calculating the latent heat in infiltration, it is M naught outside temperature into HFG into W naught minus Wi. I'll tell you what is this W naught and Wi. So this is the humidity ratio. What is W? W is called as humidity ratio. Now, This HFG, this is called as latent heat of vaporization. Latent heat of vaporization. Is it clear? Okay. Now, we don't know what is this m naught. How to calculate this m naught? We all know mass is density into volume, right? So, outside temperature, I'm putting a suffix naught in both cases. Now, this density will remain the same. This V naught is actually calculated by ACH into V divided by 3600. Now, this ACH, you call it as air changes per hour. See, the property or the nature of the air doesn't remain the same. It is going to vary. So that variation is accounted in this. And ACH will normally carry a value in the range of zero point 0.5 to 2. Now you may have a question in mind, what is this zero point 0.5 and what is this 2? So 0.5 it stands for tight buildings and 2 will take, ACH will take a value of 2 for loose buildings. Okay. So all these things you can get from the solar radiation heating load calculation data, right? So how we have to calculate this? I'm just recalling once again for infiltration alone. Under infiltration, you have two parameters. One is the sensible heat infiltration and latent heat infiltration. Sensible heat infiltration is mCp into delta T. M, you know, it is a mass of outside air. Cp is specific heat of outside air. I have not mentioned, I'm just putting it here. This is specific heat of outside air and this is a temperature difference. Likewise, for latent heat, you have M into HFG into difference in humidity. So again, M, how we will calculate? Density into volume. What is this volume? It is not just the volume of the building, but the volume of the building multiplied by air changes per hour. Okay. Now, here you have seen V. So, V is nothing but the entire volume space of the building. Say it's 3 meter by 2 meter by 2 meter, then it is 3 into 6, 6 into 2, 12. So, this V will take the value as 12. And we have seen what is air changes per hour, and it takes the value between 0.5 to 2, right? Now, we are done with this. Before, before moving to the internal load calculation, we have one more parameter to be discussed. That is called as bypass factor, right? Bypass factor. What is this? I'll tell you. See, suppose the air is actually entering a coil without any change, that is totally unfiltered or uncensored, how it was present outside, the same way it has entered inside without undergoing any change in any of its properties, then you call it as bypassing. Okay, so if a coil, when I say a coil, it's nothing but a cooling apparatus. So if a coil has a value of BPF greater than 0, then definitely some quantity of air, okay, maybe 10% or 5% or 20%, some amount of air will be directly entering into the conditioned space and becomes a part of the building cooling load. So this is called as bypass factor. Yes, so we are done with the external load calculation, right? Now coming to the internal load. The internal load calculation. So this is mainly again, you have three types here. The first one is due to the occupants. Occupants means we human beings, any pet animals, okay, so anything like that. And then you have the lighting. Suppose you are using a normal lighting or a LED source, okay. Then the third one is due to some equipments and appliances. Equipments and appliances. So this can refer to TV, fridge, AC, okay, washing machine and all those things. So when I say occupants, that is sensible heat and latent heat. In the picture that we saw earlier, we had four occupants, right? So first we have to consider the number of people multiplied by solar heat gain factor into cooling load factor. Okay. So number of people was 4. 4 into whatever this heat gain factor given in the question and whatever the CLF which is given in the question. Already we have discussed the meaning of CLF and SHGF. Okay. Next we have that is the latent heat. So when I say latent heat, again it is number of people into latent heat per person. See here you don't have to worry about the humidity ratio and all and keep calculating. Directly this will be given in the question so that you have to multiply with number of people. Okay. Now come the second one. This is all with the first that is due to occupants. The second one is due to lighting. So here when you calculate for lighting there is no latent heat, there is only sensible heat. So this is calculated using the formula installed wattage. What is the watt that is specified for your light? Okay, into usage factor. I'll tell you what it is. Into ballast factor. That also I'll tell you. I'm just listing it out here and then I'll brief each one in detail. And next, of course, you have the CLF, which you know better than me. Okay. So we have reinstated the same point so many times, so you should be clear with that. Okay. You know what is installed wattage, whatever watt that is specified for that particular light, and you know what is cooling load factor also. Then what is this usage factor? Imagine you have 5 lamps inside your room, and at the time of calculating the cooling load, only one lamp is in the switched on condition. The other 3 are not on. So in that case, you will consider only that one, right? So it accounts for any lamps installed but not on at the time of calculation, but not on, right? So that is called as usage factor. Next, you have ballast factor. So this is a load that is imposed by ballast. Ballast is a small device which is used in fluorescent lights. So what is the purpose of this ballast? I'll tell you. So it's actually used in the light's circuitry to restrict the amount of electric current that is traveling through it. Okay. It's a sort of regulator. It will regulate how much of electrical current should pass through the light circuitry. So this is the purpose of the ballast. So how much of load is imposed by the ballast? That is called as the ballast factor. Fine? Yes. Now the third one is heat due to equipments and appliances we saw. That's the third one, right? So this is the third one. Here again you have the sensible as well as the latent. So here you have again the installed wattage into again usage factor, whatever we are seeing here, okay, into CLF. Likewise, when you calculate for the latent heat, it is going to be installed wattage into latent heat fraction. That's all, right? So again, looking into this internal load calculation, we have three contributors. One is the occupants, we human beings. The second one is the lighting effects, and third one is equipment and appliances. So when we calculate the occupants, heat generated by the occupants, you have to calculate the sensible heat as well as the latent heat. When it comes to lighting, only the installed wattage and the usage factor will be considered, and of course the ballast factor since fluorescent light is used, and then you have the cooling load factor. When it comes to equipments and appliances, we have sensible heat and latent heat. For all the appliances, you will take the individual wattage for that appliance. Say if it is air conditioning, then what is the wattage for the air conditioning? And what is the usage factor? Whether it was running all, say you're calculating the heating load only for the daytime, that is for the, say for the 8 hours. Okay. So for that 8 hours, was the washing machine running all the time or only for 2 hours? So in such case, you will consider the usage factor. Then you have the cooling load factor. Likewise, for latent heat of the same appliances, you will consider the latent heat fraction. Is that clear? So a short summary or a quick revision of what we have discussed in today's lecture. Yes, we have actually started with a picture of this building. So in this building, we could see that there are participants, that is occupants, as well as the solar heat radiation. So there are solar heat source as well as the internal heat source. and at what condition we need heating or cooling, that we have seen. And before moving to the procedure of calculating the heating load and cooling load, we saw four parameters. What is sensible heat? That is temperature difference should be there. What is latent heat? That is moisture content difference should be there. What is cooling load temperature difference? That is difference in temperature between inside and outside the room. And solar heat gain factor, that we have seen. Okay. Next is the heating load. When I say heating load, now we are going to calculate the heating load for this picture. So external heat source and the internal heat source. So external heat source, we have only the sun. So rays from the sun is passing on opaque surface as well as penetration surface as well as infiltration, right? So for that, we have seen the individual formulas, how to capture, and whatever constants involved, what is the meaning of the constant, what is the physical significance, I have explained. Then coming to the second part is internal load calculation, where we consider only the occupants, lighting and equipments individually. Of course, for the lighting, we do not have any latent heat calculation, but for the occupants and the equipments, we do have both, and the individual formulas for this is given here. So this is all with the calculation part. So this is only the empirical formulas that are given. In the following lecture series, we will take one sample problem. We'll try to solve it. Okay, that is using these formulas, how we are going to solve it. So that we will see. And when I solve, you can also do it step by step. So thank you so much for your patience and listening. Get back to me if at all you have any queries. Thank you so much.